Teachers and students, and staff, we're going to do a drill. This is only a drill. We're going to go into soft lockdown. So all students return to your classroom or be inside a classroom behind locked doors. Teachers, make sure all your classroom doors are locked. You may continue to teach, you continue to instruct. Just be aware that we are conducting this soft lockdown in coordination with TPD and school safety. So you will see some presence in the hallways. But again, ignore what's going on in the hallway. Continue to teach. Stay behind a locked door. Soft lockdown. This is a drill.
Okay. All right. Teaching us does the best job. Yeah, for yesterday. Do we have to do today? Okay. Okay. Yeah.
TPD.
All right, so you all did some excellent multiplying. Very good. It's important that you do this stuff. When I ask you, it's not just for me to do. I'm not going to do it. What answer did you get when you multiplied this together? X cubed plus 8. Very good. Okay. And so you did the work and you got x cubed plus 8. That's because these bubbles here, when you multiply them together, are a special pattern. So these two bubbles, which I lovingly call the small bubble and then the big bubble, small bubble, big bubble, because they're in a special pattern that we're going to learn just now, they're always going to multiply together. A bunch of stuff is going to cancel out, and we're just left with that x cubed and that 8 term in that whole multiply process, okay? And it's because of that special pattern that we're left with here. These two terms happen to be called sum of cubes. Why do you suppose it's called sum of cubes? Because it's a sum, addition, right? Okay, so it's called sum of cubes because it's got a plus sign and sum means addition. The other thing is that these two terms are perfect cubes. X cubed is really x being cubed. And then 8 is what number cubed? What times what times what gives you 8? 2. 2 times 2 is 4, times 2 is 8. 2 times 2 times 2 is 8. And so 8 is what we call a perfect cube, and x cubed is a perfect cube, obviously. All right, so what we want to do today is be able to recognize some perfect cubes. So we're going to just make a small list here of some perfect cubes. What is 1 cubed? 1, okay, good. And 2 cubed is 8, and 3 cubed is 27, very good. 3 times 3 is 9, times 3 is 27, okay. And 4 cubed is 64. 4 times 4 times 4, 16 times 4 is 64. 5 cubed? $125, 125. 5 times 5 is 25. Times 5 is $1.25. All right, 6 cubed is 216. And again, if you don't know these, you have calculators, ladies and gentlemen. 6 cubed is 216. 7 cubed, my personal favorite. 343. 343. The only reason I remember this one is because 3 and 4 is 7. 3, 4, 3. I just like memorizing things like that. Okay. 8 cubed is 512. I don't know what 9 cubed is. Let's see. 9 cubed, 729. Yeah, 729. And what's 10 cubed? 1,000. Yeah, okay. So these are nice perfect cube numbers to know. You'll see all these numbers today. 5 And so hopefully you were writing down that list, because that list will prove very, very useful to know all those perfect cubes. But again, you have calculators. But all of these are perfect cubes. And today it's important to know what the base is. Though this number is the perfect cube, here is the base being 10, okay? 729 is the perfect cube, the base being 9. So today it's important to recognize what the base is of those perfect cubes. So here we go. Example 1, factor sum or difference of cubes. So today is really just going to be practicing a pattern. I don't normally teach patterns, but it's the best way just to know the pattern for sum and difference of cubes. It's an easy pattern. It works every time if you have sum or difference of cubes. So here is x cubed plus 8. Do you think this is called sum of cubes or difference of cubes? This is sum of cubes. All right, and what we want to know is we need to figure out the bases first. And so, well, x cubed, the base would just be x being cubed. And what cubed gives you 8? 2. All right, so we're going to rewrite this little x cubed plus 8 into, so we can see the bases of those perfect cubes. And then once you recognize the bases, sum or difference of cubes always, always, always factors into small bubble, big bubble. And so that's sort of the key word I'm going to give you today. Small bubble, big bubble. So you need to set up your small bubble, big bubble structure. And the first thing that we're going to do is set up the signs. The signs, the pattern for the signs is the same every single time. We're going to keep the sign. Then in the large bubble, we're going to change the sign. Whoops. We're going to change the sign. If it's positive, you're going to change it to negative. Change the sign. And keep the sign, change the sign, always positive. Keep the sign, change the sign, always positive. That's the pattern every single time when we're factoring sum or difference of cubes. All right, so then we need to fill in the small bubble. The small bubble is just whatever our bases are, which is kind of nice. So here our base is x. The base of 8 is 2. So we fill in the x and the 2. So that little bubble is really easy to do. It's just made up of those bases, and essentially it keeps the same sign. All right. Now to fill in the big bubble is the pattern. The pattern is square the first thing. X squared is x squared. Multiply in the middle. We're going to multiply our two little bases together. So 2 times x gives me 2x. And then we're going to square the last thing. So 2 times 2 is 4. That's it. So the big bubble, square the first, multiply in the middle, square the last. That's all it is. And it goes super fast once you learn it. So this always factors into this small bubble, big bubble pattern. This is it. This is how it factors. And again, this is what we did. This is number 1 that we just did. And if you were to multiply it all together, you would get just x cubed plus 8. All right, all those little middle terms would cancel themselves out. Okay. What do you think 27x cubed minus 125 is called? Difference of cubes. Yes, difference of cubes. Because of the subtraction sign. Makes sense? Difference of cubes. So again, our first job is to figure out what the bases are. What cubed gives you 27x cubed? 3x. Yes. 3x times 3x times 3x would give you that 27x cubed. So be careful when there's an extra number in front. And then what cubed gives you 125? 5. Sure. So these are our bases, and now I'm going to go ahead and just set up my my bubbles. Small bubble, big bubble. Small bubble, big bubble. How do the signs go? Keep, change, always positive. So what sign am I keeping? The negative. I'm keeping that different sign. Keep the sign. Change the sign. What does it change to? Positive. Change the sign, and then always positive. So the signs go minus, plus, plus. And what goes in the small bubble? 3x and 5. Yeah, just plug in the bases. And then to fill in the big bubble, the pattern is square the first thing, multiply in the middle, square the last. So we're going to square the first thing, which would be 3x times 3x. What is 3x times 3x? 9x squared. 3x times 3x is 9x squared. We're going to multiply in the middle. So we multiply 5 times 3x and get what? 15x. And then we square the last thing. 5 times 5 is 25. That's it, ladies and gentlemen. That is factor. You'll never be able to factor double bubble, this big bubble. It will never work. So that's as far as it goes. Okay. On number 39 and 40 in your homework, in your classwork today, there's a GCF first. So I did number 39 on the board. So you can see that when you get to 39 and 40. So keep the sign, change the sign, always positive. And then square the first, multiply in the middle, square the last. Every time. All right. The second set of problems is factor by grouping. How many of you had Mr. Boland in middle school for math? Mr. Boland. Yeah, so you already know how to do factor by grouping. And it's a great method. Maybe you learned it, but in Algebra 1 if you didn't have Mr. Boland. So we're going to do the factor by grouping method. The factor by grouping method is really, really useful when we have 4 terms. And so you can see we have 1, 2, 3, 4 terms here in this polynomial that we're going to add together, or combining rather. So we have 3x cubed plus 7x squared minus 12x minus 28. When we're doing factor by grouping, when you have like 4 terms, we're going to split those terms up. And then it's basically doing GCF over and over and over again. Okay, that's the process, greatest common factor. And so I'm going to split my 4 terms into groups of 2. And so I have the first 2 terms, and then I have the last 2 terms. Now you'll notice where I split it, that negative is attached to the 12x. So don't separate your negative from your term there. The sign is attached to the number. So then what we're going to do is just look at these first 2 terms and ask ourselves, hey, what's the GCF? What do those 2 terms have in common? What do they both have? An x squared, sure. They both have an x squared. And what we're going to do is we're going to take out that common x squared and ask, well, what's left over? 3x plus 7. How do you know if you did that right? Distribute it out. Yeah, so all we're doing is undistributing. So you can check by distributing. X squared times 3x gives us 3x cubed. X squared times 7 gives us 7x squared. So we're really just distributing in reverse. undistributing. Then I'm going to do the same thing looking for a GCF of the last two terms. So looking at negative 12x and negative 28, what do they have in common? Negative 4. We're going to take out whatever sign is there. We're going to take out a negative 4. Always, always you should take out a sign, whether it's a positive or a negative. We're going to take out a negative 4. And if I take out that negative 4 from each of these terms, what's left behind? 3x plus 7. And again, you just want to double check really fast to make sure you did it right. Negative 4 times 3x gives me negative 12x. And negative 4 times 7 gives me negative 28. So what happens is we took 4 terms. Well, now we have 2 terms. All right. And now we're going to look again at these 2 terms and say, hey, these 2 terms have something in common. What do they have in common? 3x plus 7. They both have a common factor of 3x plus 7. They have one thing in common. So we're going to undistribute that and pull it back out in front. And what's left behind? X squared and the minus 4. So I'm taking this common factor and pulling it, undistributing it to the front of the line, and we can see that we have the x squared minus 4 left over. That is the process for factor by grouping. And maybe x squared minus 4, anybody notice anything about x squared minus 4? That one actually goes a little bit further if you wanted to. I don't think you need to do it today, but we will on Friday. Goes a little bit further into x plus 2, x minus 2. First times first. I don't know if you remember that. It goes a little bit further. You'll see that on Friday. All right. Let's look at B. We have x cubed plus 2x squared minus x minus 2. Again, there's 4 terms there. So we're going to split them up and say, hey, what's the GCF of the first 2 terms? X squared. They have x squared in common. What's left behind when I take out the x squared? X plus 2. Very good. And again, double check. You can do it in your head. Just make sure you did it right. X squared times x gives me x cubed. X squared times 2 gives me 2x squared. And then again, we look at the last 2 terms. There's always something we can take out. What can we take out of the last 2 terms? Negative 1. Yes, we're going to take out a negative 1. Sometimes it might be a positive 1, but you can always take out something. If I take out a negative 1, what's left behind? X plus 2. And again, you can check by distributing. Negative 1 times x is negative x. Negative 1 times 2 is negative 2. And then we do the GCF one more time. What do they have in common now? They both have an x plus 2 in common. So we're going to pull out that common factor. And what's left over? X squared and the minus 1. That's why I use colors here. I think the colors are super duper helpful. And I do want to point this out. X squared minus 1 does factor a little bit further. And I just want to remind you, first times first has to be x squared. What times what is x squared? X times x. Last times last has to be negative 1. What times what is negative 1? Negative 1 times positive 1 gives us that negative 1. So this is what we would call fully factored or factored completely. I think today you get to stop here, but on Friday we got to go fully factored. All right, ladies and gentlemen, do you have questions for me? All right. So, page 249. Write the original problem. The first set of problems, there's not a ton of work to show. It goes really, really fast, okay? Small bubble, big bubble, fill it in. Okay, I wonder how long my flash drive is going for. Yeah, you'll call me in. We don't go to the house. I know, we're all done. Oh, thanks.